Welcome everybody. This is our little demonstration for TWAIN project. So TWAIN is focusing on how to use data-driven techniques, data itself, together with artificial intelligence towards asset management, towards operational maintenance of wind farms, particularly focusing on integrated wind farm control. So different ways to operate the turbines, again, fed from data from different textures and also coming from different users. They also come with their challenges. And this particular demonstration is going to be taken from our colleague SoftServe, a very important partner for TWAIN. And we have been working on the platform for about 2 years now, and we want to show you the latest, the version of it, together with everybody who is a part of TWAIN in terms of the development side, as well as end user side. We also have additional people in this workshop, in this demonstration today, coming from data management side of things, as data protection officers, etc. We are recording the meeting, so hopefully that is okay for everybody. And that is also going to be a part of sort of our public delivery. So for the people who didn't have the chance to register or to be here with us today, they can also follow it up later on. So whenever you're ready, Petra and the team, please take it away.
Sure. Let me just share my screen. Yeah, welcome everyone. I think a great way to kick off December. For those of you who have advent calendars, you can consider it as your day one. So this one might be a little bit different, but we want to make it, as real as possible. So hands-on, real software, which we've developed and deployed. As Tuhfe mentioned, the TWAIN is the decision support environment with advanced wind farm control. So the main focus is around the tools, but obviously tools gonna need data. So just a quick sort of intro that what is actually TWAIN in terms of software. So we have a couple of components that are exposed to the end users, and our end users could be researchers, could be operators. And one of the main components, which I'm gonna log into now, is Jupyter Notebook. And Jupyter is something that is probably the place where researchers spend quite a lot of time. And that was also very important for some decisions that we made. So now it became sort of a centered piece of the platform and the tool set, and it evolved in a way that basically for the large extent people might actually spend their whole journey with TWAIN inside the Jupyter Notebook. So when it comes to data, what data are we talking in TWAIN? So broadly, we have two categories: time series data, generally represented by SCADA, and static data. You have farm layouts, power curves, so the two large groups. Now, in terms of formats and data types, we settled down on CSV as a primary data format, which is quite ubiquitous, common, and tested. So every data journey in TWAIN will start with a small and humble CSV, which most operators, researchers would have, and that's what I'm gonna start with. But before I do that, as I mentioned, TWAIN is first and foremost about tools. So this is why we expect people to come to TWAIN and actually trust us their data. Obviously, the platform is secure, it's been tested, but they would need a good incentive to bring their tools, to bring their data, and for that, the other members of the consortium are developing some great tools, and we integrated them on the platform. So as people would land in this Jupyter Notebook, that would be a folder. For now, we call it a link to shared folder. Might change, but this is a place where we have the versions of the models that have been tested, verified, and they will be shared. So everybody who's going to have access to TWAIN going to see exactly the same list of models here. So we just recently integrated, as you can see, 2 weeks and 3 days ago, we just integrated those two sets of models. So one is the fatigue damage, and the other one is a TWAIN wind farm model, which is pretty much using the Flores interface for a couple of for a couple of different calculations around energy production, loads, etc. But with the consideration of wake. So yes, models are the reason why people come. So if for anyone who wants to see the models, what they are, what they're capable of, it's as simple as copying the model folder and then pasting it in your root of your notebook. So I've done that already. So yeah, we have this latest integration of the models based on Flores interface, and inside it we have 4 examples, which are kindly provided by our colleagues from TWAIN. So I'm just gonna open actually all 4 of them and run so that you can have a sense or feel like why, what could be the models here and why people would come to this environment. And then we'll go to the data part. So we're running notebook is quite simple. Just hit this restart kernel, and we're gonna go and actually run all 4 of them. So this is, I guess, a bit of a surprise, maybe even to most of the consortium, because we were just integrated this on Friday. So it's kind of new development, updated version of model. Maybe after this demo, you'll be more interested in going to Jupyter and having a look at the tools that have been developed. So as you can see, yeah, they run on this environment, no issues, producing results on those test scenarios or those examples. So this one is power production. So I'm not gonna focus too much on them. You see there's a farm layout here. It's just to show you that, yes, it's first and foremost models, and it's fairly easy to explore models, understand what's inside them, what do they require to run, how they run. Unfortunately, I'm not that proficient yet on the wind farm research. But yeah, I think it's gonna be great value for the users to have this taste of the tools available and what they can offer. So let's say, on a final stage, there'll be a lot more models like this. People would come and explore them, and then they would decide that it's actually good enough for them to come and run some of their simulations or get some results. And for that, they would need to bring in their data. And as I mentioned, everything starts with a small and humble CSV file, and bringing files to Jupyter is fairly easy. You can use the upload button, or you can actually even also use drag and drop. That's also possible. So you find your CSV file and upload it to your Jupyter. Now, what's next? One of the things that was done in TWAIN, I think this is a really great thing, is the standardization of nomenclatures and ontologies when it comes to SCADA data. There's this challenge with different operators having different names for pretty much same signals or channels, and that could be a bit problematic when working with data or developing tools. So the idea behind this was, if we do this standardization, then we have a common ground for developing tools that are gonna be working on top of the data by fixing the nomenclatures and kind of creating dictionaries that would convert the OEM ontologies into the TWAIN native language. So in order to do that, there's a series of pipelines and things happening behind the scenes to translate this CSV into that standard. And in order to do that, the first step is to describe a CSV, because again, data comes from different backgrounds. You can have different number of columns, different names. So yeah, there is a need to in order to standardize, to have a description, and that description comes in a standard which is called over schema. And what we tested and what we've validated is obviously it could be a bit tricky for people to generate that file manually, especially if you're bringing a SCADA data file, a large file with sometimes hundreds of columns, and not all of them even would match the TWAIN standard. So it's a big effort. And as a result of that, we developed a small tool available also here in Jupyter that basically helps you effortlessly create your schema for your CSV file or your description. So all you need to do is just copy paste and replace it here. Let's see. It's the same file, and then you just run it. So it might be a little bit, some small errors, which are not really important, but as a result, you can see that a new file appeared, which is called the other schema. And that essentially describes your CSV file.
Pronto.
So, yes.
Ciao.
Is there any question or? Okay, so the other schema describes your CSV pretty much column by column. And so in terms of SCADA data, the very important part is understanding the date time pattern, because people in different parts of the world and different companies might use different standards for that. So that's the first one and important. And the second is having a description for every column in the file that would later help us using our pipelines and dictionaries of aliases to actually map all those columns to the TWAIN language. Another important parameter which we introduced is data retention. So by default, data retention is 30 days. But as owner and user of the data, you can choose to modify it in any way. Depending on your needs. So on this file, because it's going to be a demo run, I'm just going to make it 3 days. Okay, now we can save this. So now that we have both files, you have CSV file, which is a regional file that you brought with you, your SCADA data in this example, small one. The other one is the other schema, which does describe every column of your file. And yeah, the important thing about our CSV first, it should have integrity, which we unfortunately cannot verify programmatically. But for most files coming from other systems, they should have it. So simple things like having a header with column names. Otherwise, the automatic generator won't be able to populate it for you. Having a column for each name, having a name for each column, and also ensuring that your file starts with with text and not with a separator like comma, because that'll again confuse the auto generator. And at the end of the day, it's always a good practice to have a look, review it quickly, make sure there's nothing weird in this file, and that's why we have it as a preview. But you can also work with this file by opening it in Jupyter. Now, the good part about this, if you say uploading data for multiple years, for a longer period, and you always keep on using the standard schema, then you will not have to repeat this exercise because you would already have this schema file that works for your cases, and you'll be able to use it yourself or share it with your colleagues. Right, so started from humble CSV SCADA file. Now we have a second file, our schema, that describes it. So we do all that to be able to ingest this data into TWAIN environment. And ingesting means first, converting the signals or channels to TWAIN nomenclature, and second, converting this CSV file into the table, which gives you a lot more flexibility and has a lot more, it's fairly quite easy to work also on the Jupyter. So for upload, we always need this pair of files because obviously system cannot predict any CSV. And as you can see here in this first cell, I'm just gonna insert files as they are requested. So you just do the same thing as with generator, you just copy paste, and then make sure that your our schema file goes to the first part, schema file, and then the your CSV will go to the second file, which is original data file. So I'm using same file's name as I did a little bit before for the rehearsal, so I'm not going to change that, but it's as simple as that. And the other thing is important that those two files have to have exactly matching names. Yeah, there should be one-to-one relationship between those files. But as you've seen with the Avro generator, it already takes care of that, and it returns you the Avro schema file with exactly the same name as the CSV that you fit it. But then we can also implement an extra layer of validation to make sure that yeah, users don't make a mistake here. A very important note is that by default, all the ingestions that are gonna happen in Jupyter using this code, they're gonna be private. So in case user wants to do a public upload, they would have to introduce another argument and set it to public. So this is a safety mechanism to ensure that users by mistake do not make their private data set public. All right, so once this is all ready, we can restart this kernel, and that will start the ingestion. And in the meantime, I'm going to switch to a different component, which is called Minayo, that is working behind the scenes for the ingestion. And this is the login. We have SSO login, so once you log into one component, you then don't have to repeat the process for other components. So we started data uploads with Minayo, and then eventually we moved to Jupyter for a couple of reasons. One of them is usability, obviously. It's more convenient for researchers, but they also give you same opportunities for uploads, apart from large SCADA files, which would have to go through Jupyter, as Jupyter supports batch ingestion or parallelization. So it allows you to ingest a lot of larger files than Minayo. But the underlying privacy and security part is pretty much the same, and we had a couple of iterations before we arrived at this, but basically what is now in Jupyter is kind of mimics what was originally available on Minayo. So we have this Avro generation bucket or folder where you just drop your CSV and it generates an Avro, just as I showed you in Jupyter. And then we have clear separation between static and time series or SCADA files. So again, if you have SCADA files, they would go into time series bucket, static will go into static, so there is no confusion there. And for each of the buckets, there's also reports. So once the ingestion is completed, you obviously want to know how it went, whether it was successful or not. I mentioned that all the uploads in Jupyter by default are private. So in Minayo, that's handled a little bit differently. So, and if you want to do a public upload, you just go to the public folder. And if you want to go to the private upload, you go to your organization folder, add your user folder, and then drop two files there. So either way, yeah, it gives you opportunities to ingest any type of CSV files, time series, and static. It could be either public or private based on your needs. And we kind of retain this way of uploading in case it is more friendly to users who are not so proficient in Python or coding. So that's why we kind of have two of them living side by side. But as we envision it with the that Jupyter probably might be the preferred way, at least for the researchers, and this could be pretty much a tool where you spend most of your time and you don't have to switch to other tools, even though it might be not so complicated. So yeah, that's why in this notebooks we have a list of buckets, just showing you that you have access to exactly the same buckets as you would have in Minayo, starting from Avro generation to bucket for static data, bucket for results for static data, and the same for time series or SCADA. So I think we can check here and then confirm in Jupyter. So once you started ingestion, at some point you would get the result. And result is a simple file, txt file. Then if it's success, obviously there's no really need to go deeper inside. You know that your data has been ingested. If it's failed, you can download it and have a look. And we try to highlight some of the common errors that we can catch to help users fix them and then re-upload their data. So yeah, you can see the last successful upload was the one I was doing my preparation. So might take a couple of more minutes before we get the latest upload, which I just did. So maybe in the meantime, if you have any questions to this part of data ingestion, you can answer them.
I don't see any questions in the chat, Petra, but just for iterating again, I would want to ask, what do you think the maximum size of the data we can upload, given the constraints on the memory as well?
Yeah, so as you can, good question. As you can see, the allocation we have for each Jupyter notebook, we have allocation of 8 gigabytes of RAM and 10 gigabytes of storage. And so we can concurrently have about 7 or 8 sessions. So that means for storage, it's up to 10, but realistically for with all the limitations of the platform, what we tested, the limit for this file, for the SCADA file to ingest it, actually not to upload it to Jupyter, would be around 1 gigabyte. As I mentioned, for the MinIO, we had, because it doesn't chunk the data. So there we can upload files up to 100 megabytes, which might suit most of the users and definitely all of the SCADA, all of the static data. But yeah, for larger SCADA files, definitely Jupyter. And I think that up to gigabyte data should be, that's more on the infrastructure side, but given the chunking and that Jupyter does, I think that should be no problem. It might take more time than definitely the sample. I think we tested files well over 100, closer to 200, and it was in minutes, so it's not like you'd have to wait too long. Okay, let's see if we have a new result. Yeah, as you can see, so the upload, the ingestion was successful just recently, and we can follow the same in Jupyter. So what this cell does is retrieves all the ingestion reports, and it also sorts them by recency. So you can see I have the same ingestion report. It's unique. It has its own timestamp. One thing to note, that timestamp is in UTC, so that's why it's not matching my machine time. So that's the ingestion part, and then you can take any report, any file here, and open it, and I'll give you a little bit more details. So that's the ingestion part. The next part that goes after the data ingestion is data discovery. So for that, we'll go to another tool which we have in the platform called Open Metadata. And as the name suggests, it will bring the metadata to your data. Yeah, a lot of data. But as you remember, we had a CSV file which has some columns, some values to them. And we described it with our schema. And once ingested, that CSV file is going to be transformed into the table. And for all SCADA data, because it's standardized, that table follows what is called in TWAIN the common data model. And it's pretty much just a list of nomenclatures for SCADA channels names, which we agreed and standardized in TWAIN. As you can see, we already had 3 iterations. So we started with the initial list based on the OEMs that we had in the data sets within the consortium, and then we augmented them by adding additional columns based on the requirements. So this is, this can be changed if we see a need based on the tools that we're developing. But as I said, it's just really describing you every column in case you might not be familiar with what this name stands for, like VTOR _ W _ average. You can see the data type behind it, and you can also see the description. So the idea is that that would help people who bring their data, and also tool developers, to better understand this common language, this standardization of channels that we use in TWAIN. And because this common data model is the same for everyone, and it doesn't reveal any sensitive data, so that's just the metadata. So it has this name, and there's no issues there. But what we discovered with the static data, once we wanted to move past the initial data, is that some of the static tables that we were testing, they might have something sensitive potentially. So to make it really private, what we did is actually hashing of the static table name. So if someone would go to open metadata and would try to look up for a table that they don't own, they would see just the hash name. So inside, there's nothing confidential. It's just the mapping and names of the channels based on Avro. But in case this name would have contained a wind farm name, an operator, or something else that people might not want to show on the background, this is hashed, and as a result, in static ingestions in your results, let's see, I'll show you one. So if we download this one, to downloads, and you would see that in this in the successful ingestion for static data, we actually give mention this hashed table name, so that people who upload it actually can identify it, because it might be not clear how the name was transformed, but because this was done for the privacy and security of the data, it's a low inconvenience to pay for it. So that's the first part of data discovery, discovering metadata for your data. The other tool which we have, which helps with the data discovery, is called Superset. And Superset is business intelligence tool. In simple ways, it just helps you build visualizations, graphs, and combine them into dashboards to visualize your data. So not, in this case, this won't be metadata, but the actual data. And so what we did is we prepared sample dashboards, or like template dashboards, for every organization. And this means that the data that every organization has in this common data model, the SCADA data, is separated all the way through ingestion, storage, and access. So we know for every single record in this common data model who is it owned by and who can access it. So that means that yes, people will be only able to visualize here the data that they actually have access to, and the same goes to further working with this data in Jupyter. So for now, there's not much here, just some general ideas about graphs, but what people can then do is develop graphs based on their needs, add them. And this, the good part about those dashboards, that they are actually shared for the organization, so you don't have to constantly redevelop, but instead work a little bit more into the collaborative environment. So yes, those two main tools for data discovery, a natural second step after data ingestion to better understand what you have actually ingested, especially if you're sharing this data with other colleagues, for them also a chance to have a quick look at the data and have some early insights. All right, so let's have another pause here to see if you have any questions to this part of data discovery, the two components which we covered, metadata, open metadata, and superset. Okay, if no questions, then we're gonna go back to Jupyter, where I showed you the initial ingestion and also the tools available. So yeah, those example tools, they don't exactly run on the files that I've uploaded, but I'm gonna show you how we envision that people would actually use the data that is ingested in TWAIN. If you recall, it's not a CSV anymore, it's not a file. If you want to work with the standardized TWAIN data, it would be a table. So to help people getting started, we prepared like a welcome notebook that helps people understand how to work with the data, see which data is actually available to them, see some data frames, and we're gonna add obviously more to this notebook to make sure that people have access to the main functions in hand, also to average generation, to ingestion. But for now, this notebook really shows you what interactions you can do with the underlying data, which is already part of TWAIN, which was ingested. And so what it does basically on your authorization token, or by knowing who you are because of your login, it can show you some useful information, can show you the files, the original files that you have access to, and those could be either SCADA or time series, so you can work with those. It also shows you the tables which you have access to, and again, because you're rarely would be the one sole person in your organization, there be probably other people, so it's not necessarily that you would have to upload every single file that you have access to. Most of them could have been uploaded by the members of your organization, could be also public or shared by third parties with you. So that's where you can see a list of tables, the common data model, which I showed you in open metadata, which is TWAIN place for all time series SCADA data, and a bunch of static info tables. Most of them are hashed since they were uploaded once we introduced this feature. And then to ease work with those tables, the way the data can be fed to tools in Jupyter or analyzed is actually creating data frames from the tables by simply using SQL query language or SQL. So this one is from common data model, which is our SCADA data. It retrieves just first 3 rows, not to keep it heavy, but you can see that there are 139 columns in this common data model. It doesn't mean that for every data set you're going to have exactly the same number of columns. It depends on the OEM of the data and the mapping that we have in place, but generally you would have a few dozen column in this table. And then because it's a table and you can use SQL, so you don't have to actually extract all the data. You can really limit it to a column or number of columns that you need for your particular applications, and that should help with the memory load of running tools and simulations on the environment. And that's something that we're gonna test further with our partners to ensure that the memory limits we have here, 8 gigabytes, is sufficient for extracting data frames of that are required for different applications, and also being able to run applications with those exact data frames. And that's pretty much all there is to TWAIN now. So really, if I would have to sum it up, that people would come and stay for tools, but data part is also really important for us, and to ensure that people trust us, we try to get every measure to ensure that their data is private and secure. Took our time, and we started really with some public data, and it's been some time that we actually were able to prove partners that data in platform is fully secure by doing security testing on the platform, enhancing security on the infrastructure, doing some testing, improving this structure with buckets, and separating between organizations, which is very important for the future, but also in case of our consortium, where we have operators that could be competing with each other, and obviously we don't want them to see each other's data. But at the same time, we have researchers who should be having access to everyone's data. So it was really about finding this balance between usability, cooperation where possible, but always ensuring data privacy and security in the first place. So in case you wonder how that all handled, we have another tool which I don't have access to, but our dev team and admins have access to. This tool is called Kicklock, and that is a tool behind the scenes that users don't see, that actually does all the login, authorization, authentication. This is where we set up groups matching to organizations. We give those groups policies or rights, saying literally what being in a certain groups allow you to do with all of these components. I think we have 20 more minutes, so if you have questions to this part, then I think it might be valuable. If you want to see it, then I think Paolo can show you quickly what it is and what it does.
But yes, Pavel, are you ready?
Yep, I'm ready. Okay, so I will briefly show my screen. Just let me know if you can see it. And yes. I will try to show you, like, first the way for the new users to come in. Maybe it will actually answers partially some of the questions raised right now regarding like discoverability once you're in, to know what is available. And at the same time, you have one of the few chances to see what's under the hood, because I will be juggling the different accounts and actually enabling myself. So let's say I want to join the TWAIN as a new user, and I have like at least like a handle or URL to one of the components. It doesn't really matter which ones, but if I want to go with that route, I can try to log in, and if I don't have a login already created, I can choose to register myself. This part will be worked on because we still will have some like actual terms and conditions that need to be applied, and you need to actually be compliant with them and choose to accept them. As you can see, they made a lot of those, the test accounts, but I can try to make a new account. I'm lazy because I will try to just create a next user with some password. For this, I will remove it later, so just disregard it. And for your real user, if you choose to register, it's really needed to go with your password for 2 reasons. The system will try to confirm your email, and unless you are confirmed user, you cannot really make any use of the system, and your account is not enabled unless you confirmed your email by just getting the email and clicking the confirmation, the usual stuff. At the same time, with your email, the admin at this point, like in this very moment, me, but eventually the person responsible for administrative tasks of enrolling users will have a much easier job to figure out, out of the weeds, whoever has registered and where do they belong. Because when I create a new user, say let's finish this this work. I will do some example, which means I will not get the email, but I have a ways to do it myself. And I will agree to those terms and conditions. It tells me I need to register, verify my email. I know my email is bogus, so I will just now we will show you what's under the hood. So as an administrative account, as an admin user, I have full power over the users here, and I can look at these created ones, and I can see, okay, there is one that's actually blinking red right now, that it's not verified, which means the user didn't create it. I don't have really chance right now to do it, but having the administrative rights, I can actually do it myself right now for this account. What you see right now is the administrative panel of the Keycloak. Keycloak is this open source tool that enables you the single sign-on and can act like as a first authorization layer and authentication layer too. So it will tell you the system, who are you and what are you allowed to do as a user. I think if I registered right now as a test user 38 with no regular actual meaning, if I go to look at this user and look at his groups of that, it will see that, okay, this is a user with something called default access group. So if I'm going right now as this into any kind of component of the system, I successfully enrolled, but does it really mean anything? I've entered the first component, and the only thing I can see right now, so like if you can recall what Petrov has been showing you, he was able to see a bit more of this here because he was able to see data that is private. As a new user, I'm only able to see data that is public, and I can only interact it with this by looking at it. I cannot drop any data. I cannot upload whatever is public. Maybe I'm able to see what's there and explore to see. Additionally, if I'm a new user, I can go to Jupyter and it will fail because for freshly registered users that are not verified, we took some free assumption that we don't want them to just take the resources. So unless the administrator takes the job of actually assigning the user to any existing group with actual rights to operate on the TWAIN system, this is what we will see as like a greeting message. Well, I'm sorry, but you are not able to do anything unless you want to explore some other sub-services, which Petro has shown you. So you can look at the Minio, which we've seen previously. You can explore open metadata, and you can explore supersets. So like once you're in the system, you kind of know from one place or another where to go, what to do, and we kind of took the effort to make this system or components to actually reference each other from one place to another. There will be probably, we will make sure that there is at least one place that gathers everything together as a part of documentation and as a part of like one ending land page that would bring this to list everything for you. Okay, so I'm having a user, but this user doesn't really have much rights to do. Now the administrative rights kick in because someone actually needs to like find you in the list of freshly created users and do something like with this user. So saying, okay, this is no longer valid, and these are redefined. Right now, the existing groups, every of those groups has defined permissions and defined access rights. Depending whether you are a researcher or operator, the rights slightly differ. And this is where it's really helpful from you as a user for the administrator to include your corporate or your organization email, because based on that it will be much easier to find whoever you are and where to assign the user. For this one, I will choose DTU. I will have, okay, so now I'm in the group of DTU, and if I go here once again, just to make sure, I will log out and do this exercise once again. 38 and 38, and now it's not failing. Now it's actually letting me in because someone has enabled me as a full access as a user with fully operative rights, right? So depending on where I belong right now, I can go, and as you can see, as a new user, I have the welcome package. So this is basically all the tools that are given to all the users by our teams, with the models, with the extra tools that enable you to the generation, the ingestion, the interaction with the data, and the how to welcome notebook that should ease you in to operating and interacting with the system. Do you have any questions to that part? I know it was brief, but I tried to really go straight to the point.
Thanks, Pavel. Again, to iterate, so the idea behind this grouping for the participants, for the users, is because the data is typically owned by an organization. So when you are logging in from the same institution, perhaps it was your colleague who has uploaded the data, ingested them, get all our schemas and get them in a usable format. Maybe you just want to continue the analysis looking at different aspects this time. Instead of having to upload the data several times owned by the same organization, several colleagues from the same organization can come in and use the environment a bit more efficiently. So that they can continue on their colleagues' work. So that's one of the idea behind it. So we are following sort of the ownership of the data when we're creating the users and their access levels. Right, so that also includes the researchers and the researcher groups. Thanks a lot, Petra and Pavel, for the introduction today. I think I already gave a little bit of a sneak peek what the open call is going to sound like, but I want to highlight once again. So we are working on putting more and more models to the environment every day. So after data comes in, there are several steps that the models are expected to read them, process them further, and give you meaningful results towards more and more the behavior analysis of the wind farm, and then eventually optimizing it and give you some suggestions for decision making at the end of the day. So it is going to be a decision support tool, giving you a couple of potential scenarios to follow and what happens if you follow those scenarios, basically, in your wind farm that you sort of introduced from the beginning. So the whole workflow is going to be published as a part of this open call by next year. So October 2026 is our deadline for this. So that's going to be the version 0 release. We are going to fund one applicant about 75,000 euros for trying out our environment and provide a very detailed user feedback in about 3 months. And then we have another 3 months to work on the updates for the environment, and we will release the final version by the end of the project, which is about 2 years from now. So stay tuned if you're also interested in being a part of the open call, being a part of the user journey, user experience. If you don't want to have all the, let's say, formal procedures of being a part of the open call, because at the end of the day, TWAIN is a Horizon Europe project, it's a European Commission funded project, and every open call might have very strict sort of rules to follow. And I know some companies find it a bit too much of an admin burden, and then they would like to just come in kind and try the tools. Of course, we're also very much open to that going forward. We will publish all of that. Hopefully they will be fair, so very much findable and accessible through our webpage and LinkedIn and all the other resources. Thanks a lot for being a part of our demonstration today. And thanks a lot for the recording. If you want to rewatch it, we'll make sure that the whole recording is available up there on the internet somewhere. Follow TWAIN on LinkedIn if you're not doing so, and follow twainproject.eu for our project webpage and the updates going forward. Thanks a lot for your interest, everybody. See you in the next one.